Hi there. Today's video will have this question. A raised to the power of 2 plus b raised to the power of 2 is equals to 45 and b squared plus c squared is equals to 40, and we are asked to solve for a, b and c. And we have to also note that our a, b and c are positive integers. So let's get started. So we have a squared plus b squared is equals to 45. We are going to call that our equation 1. And b squared plus c squared is equals to 40, and we are going to call that equation 2. Now, the next step we are taking is to subtract our equation 1 from our equation 2. So we have a squared minus b squared, then plus b squared minus c squared is equals to 40 minus 45, minus 40. So minus b squared is going to cancel our plus b squared, and we'll be left with a squared minus c squared is equals to 5. Now, on the left hand side, we can write our equation as a plus c multiplied by a minus c. So we have a plus c bracket a minus c is equals to 5. Now, this is going to leave us with two case scenarios. That is when our a plus c bracket our a minus c is equals to 5 multiplied by 1, or when they are equals to 1 multiplied by 5. So we're going to try looking into these two scenarios. So first of all, we'll go for the first one. Now on the first one, we have our a plus c bracket a minus c is equals to 5 multiplied by 1. So when we write this equation, we'll have a plus c is equals to 5 and a minus c is equals to 1. Now the next step we're taking is to add the first equation to the second equation. So we have a plus a will give us 2a, then plus c plus minus c is going to cancel the c, and we have 6 plus 1 is equals to 6. So we have 5 plus 1, so we have 2a is equals to 6, and finally our a is equals to 3. Now to solve for c, we can use any of the equation above. We are going to use a minus c is equals to 1. So when you substitute, we have that our c is equals to 3 minus 1, and finally we have our c is equals to 2. So we have found a and c. Now it is time to find b. So remember the first equation, that is our equation 2. The question said b squared plus c squared is equals to 40. So when we substitute the value of c, which is 2, so we have our b squared plus 2 squared, which is going to give us 4, is equals to 40. So with this we have our b squared is equals to 36. Then we square both sides, we have our b is equals to 6. So in this first case scenario, our a, b and c are equals to 3, 6 and 2, all positive integers. Now for the second part, where we have our a plus c bracket a minus c is equals to 1 multiplied by 5. Now note the difference. The other one was 5 multiplied by 1, and this one is 1 multiplied by 5. So again, we write our equation, and we have a plus c is equals to 1 and a minus c is equals to 5. And just like the other one, we add the equation. C is going to plus c is going to cancel minus c, and we are left with 2a is equals to 6, and our a here again is equals to 3. Now again, to solve for c, we substitute the value of a in our equation. A minus c is equals to 5. So we have 3 minus c is equals to 5, and finally we have our c is equals to 3 minus 5, and our c is equals to minus 2. Now to solve for our b, since we have found a and b, a and c, so we are going to bring our equation 2 from the question. We have b squared plus c squared is equals to 40. So our b squared plus, when we substitute, we have minus 2 squared is equals to 40. Now minus 2 squared is going to give us 4. So our b squared is going to be equals to 40 minus 4, which is equals to 36. So our b squared is equals to 36. Then when we square root both sides, we have that our b is equals to 6. So in this case scenario, our A, B, C are equals to 3, 6 and minus 2. So according to the question, it says A, B and C are all positive integers. So this second case scenario is wrong. We're going to go for the first one. And our final answer are equals to A, B and C are equals to 3, 6 and 2. Thanks for watching.